Good day, students. Today we'll be learning mathematics with Mr. Victor Ogunkoni. Today we'll be looking at a new topic, linear inequalities. So now let's consider a class that has n number of people in it, where n is the number is the number of persons in the class. Now, if there are exactly 40 students, 40 persons in that class, we can say that number of persons are 40. So n will be equal to 40. Now, this is an equation. Now, what if we don't know the exact number of persons in that class? Let's assume that, okay, number of persons in the class are less than 30. How do we represent this mathematically? So we say that if the number of persons are less than 30, that means n, which stands for the number of persons, is going to be less than 30. Now, this is an inequality. And this is what we're going to be dealing with under this topic, inequalities. So inequalities, we can say, are mathematical expressions such as the less than, the greater than, the less than or equal to, and the greater than or equal to. Now these are inequalities which can be used to compare statements. Whether one is larger than the other or one is smaller than the other. We'll be making use of all these inequalities. So how do we perform basic operations under inequalities? Taking our first example, which you have as 2x plus 3 greater than 7. Now how do we evaluate this? To evaluate this problem is the same as solving equations. For us to solve this inequality is the same as solving equations. The only difference here is that we have to take note of the inequality sign here. Because this is not an equation, as you can see, we have an inequality that 2x plus 3 is strictly greater than 7. So we need to know the range of values that satisfy this inequality, that will always make the left-hand side to be greater than the right-hand side. And that's what we're going to look for. That's what we're going to solve for, to get the range of values or the solution of x. So, to solve this, definitely we eliminate the constant on the left-hand side, which is plus 3, by subtracting 3 from both sides. So, subtracting 3 from both sides, we have 2x plus 3 minus 3 greater than 7 minus 3, which we have as 2x greater than 4. Now to solve for x, we divide both sides by 2. So by dividing both sides by 2, we have x to be greater than 4, which is easy. Now you can see that the same method applies when you're solving an equation, which we've just seen now. But the only difference here we have is that whenever we divide, here you can see that we divided by a positive number here. The positive number, which is 2, and the inequality sign remains the same. But when we divide by a negative number or multiply by a negative number, then this inequality must be reversed, which we'll see in our next example. So in the next example, where we have minus 4x minus 1 less than or equal to 7. Also, the same procedure applies here, where we are trying to solve for x. We know the range of values which satisfy the range of values of x that satisfy this inequality. So also, to get rid of the inequality, the constant here, we add 1 to both sides. We will have minus 4x minus 1 plus 1 less than or equal to 7 plus 1. So from the left hand side, we have minus 4x less than or equal to 8. Now at this point, you can see that for us to get the value of x, we have to divide both sides by the coefficient, which is minus 4. But if you notice here, we have a negative coefficient. And like I said previously, for us to divide by a negative number, then the inequality sign must be reversed. So dividing both sides by -4, I have x, then the inequality sign, which is less than or equal to, now changes to greater than or equal to, and we have -2. And this gives the range of values of x that satisfies this inequality. That means that if we take any value from -2 above, because inequality here says greater than, that means starting from -2 is included, -2, -1, 0, 1, 2, till infinity, till positive infinity. If we pick any value of x in that range, it will satisfy this inequality. Now, we can demonstrate this. We can show our solution on the number line. Now, let's look at the number line. How do we represent our solutions on the number line? Now, supposing we want to represent our solution on a number line, how do we do it? Supposing we want to represent x greater than or equal to -2 on a number line. Now, we draw our number line, we sketch -2. We take note of the endpoint. The endpoint here is -2. And we use our circle to demonstrate the endpoint. We have two types of circle we draw in this case. We have the open circle and the closed circle. Now, the closed circle is used when you have less than or equal to or greater than. It's used when you have less than or equal to or greater than or equal to. And then the open circle is used when you have strictly less than or strictly greater than. Now, from our inequality here, we have that x is greater than or equal to -2. So the circle for the endpoint we'll be using is the closed circle, which will draw on this point -2. And then the arrow will draw depends on the direction of the inequality. You can see the direction of the inequality here tends to the right. So we're going to draw our arrow towards the right hand side. And this is the inequality for x greater than or equal to -2. And this is how you represent inequalities on a number line. So we'll move to the next example. Move to the next example, which requires us to sketch our solution on the number line. We have 2 into 3 plus 5, x plus 5 less than or equal to 3 into 5 minus x. Now, in this example, you can see we have brackets here, and definitely from our board mass, we have to do away with the brackets. And we're using the principle of distribution here, the distributive property, where we distribute 2. To open this bracket, we distribute 2 over x and also over 5. So now, for us to distribute that, we are multiplying 2 by x, that's the distribution. 2 times x, we have 2x, then plus 2 times 5, we have 10, less than or equal to. Now, on the right hand side, we repeat the same process. We distribute 3 over 5 and x, so that we have 3 multiplying 5 to give us 15, and 3 multiplying negative x, we have negative 3x. So at this juncture, we have to collect like terms. We have to group similar terms together so that we can solve for x. So we can add plus positive 3x to both sides. Adding positive 3x to both sides, we're going to have 2x plus 10 plus 3x less than or equal to 15 minus 3x plus 3x. So for the left hand side, we can see that we have like terms here. So we can add 2x plus 3x, that gives 5x plus 10 less than or equal to 15, because minus 3x plus 3x gives 0. And now we have plus 10 on the left hand side, which you can eliminate by subtracting 10 from both sides. So subtracting 10 from both sides, we have 5x plus 10 minus 10 less than or equal to 15 minus 10. So from here we have 5x is less than or equal to 5. And to get the value of x, we divide both sides by 5. Dividing both sides by 5, we have x to be less than or equal to 5. Now this is our solution set, our solution for the inequality. That is, if we choose any value of x that ranges from 5 below, let's say 5, 4, 3, 2, 1, it will satisfy this inequality. Now for us to represent this on the number line, we're going to sketch our line. We sketch our line. Now, what's our endpoint? Our endpoint here is 5. And definitely our circle is going to be a closed one because this is less than, this is going to be less than or equal to. So we'll draw our endpoint on 5, a closed circle, and then our arrow will turn towards the left hand side. We'll draw our arrow. And this gives the diagram for this solution. This is the sketch, the number line for the solution. So in our next example, we're going to see how to evaluate fractions, inequality involving fractions. And also, we're going to sketch our solution. We're going to sketch our solution on the number line graph. So the next example, which you have as 1 over 2 half of x minus 1/3 less than 5 minus 2/3 of x. Now, as with equations, for us to solve this inequality, we have to do away with the fraction. And for us to do away with this fraction, we multiply through by the lowest common denominator. Now, if you can remember, we know that 5 has a denominator of 1. So we check what is the lowest common denominator of 2, 3, 1 of all these fractions we have here, which is 6. So we'll be multiplying through this inequality, by 6. So we have 6 multiplying half of x minus 6 multiplying 1/3 less than 6 multiplying 5 minus 6 multiplying 1/3 of x. So from here, what do we have? We have that 2 can cancel, can divide 6 to have 3, which will have 3x, because 3 times 1x is 3x. Then minus 3 divides 6, we have 2, times 1, we have 2, less than 6 multiplying 5, we have 30. And then at this point, 3 goes into 6 2 times. And we have 2 multiplying 2 to give 4x. We have 2 multiplying 2 to give 4x. And here also, we collect like terms. We group the like terms together. Then from here, we can add 2 to both sides. So we can eliminate 2 by adding 2 to both sides. So from the left hand side, what we have is 3x less than 30 plus 2 gives 32 minus 4x. And at this point, what do? We're going to add minus 4x. We're going to add 4x to both sides. We're adding 4x to both sides so that we can get rid of the term involving x at the right hand side. So adding 4 to both sides, we have 3x plus 4x less than 2 plus 4x plus 4x. So now at this point, we can see that we are now having what we want. So 3x plus 4x now gives, so I'm going to make up space here. 3x plus 4x now gives 7x, which is less than, now minus 4x plus 4x goes to 0. What we're left is 32. And then x we can now get the value of x by dividing both sides by 7. So dividing both sides by 7, we have x to be less than 32 all over 7. But we can still reduce this fraction. We can still reduce this fraction, so we can have x to be less than or equal to 4 all over, which remains 4 all over 7. You can also write this as a decimal number. So that takes us to our next example. Now, our next example, in our next example, we are now having two inequalities. We are trying to solve two inequalities at the same time. Now, the same procedure applies while solving this kind of inequalities, because the only difference here is we'll be solving the two inequalities simultaneously. So we have that 2y minus 1 less than or equal to 3 and 2 minus y less than or equal to 5. Now, in this example, we have two different inequalities. So the same method applies from the previous example, where we solve these inequalities to get the solution for y. But in this case, we'll be solving them simultaneously. So starting with the first inequality, we'll solve for y. So getting rid of the minus 1, we'll add 1 to both sides. So we have 2y less than or equal to 4. And then we'll divide both sides by 2 to get the value of y. So we have y to be less than or equal to 2. And also, from the other inequality, we can subtract 2 from both sides. So we have 2 minus y minus 2 is less than or equal to 5 minus 2. Which gives minus y less than or equal to 3. Which we can also write as minus 1y less than or equal to 3. So we can divide both sides by minus 1 to get rid of the minus, the negative sign there. So dividing by negative 1, remember what we said earlier from our previous example, when we divide by negative number, what happens to the inequality? It changes. So y is now greater than or equal to minus 3. Now these are the solutions to these inequalities. But we can still combine these two solutions to be one inequality. So from here we have that y is less than or equal to 2, and at the same time y is also greater than or equal to minus 3. So from here we have that y is less than or equal to 2, but at the same time it is greater than or equal to minus 3. And this gives the solution for this inequality. That means that any value we choose between minus 3 and 2 will satisfy any of the inequalities. So representing this on our number line, now representing this on our number line, we draw a number line. Our endpoints are minus 3 and 2, and definitely we'll be drawing closed circles because we have less than or equal to. So we have our closed circles on 2 and minus 3. Now, from the first inequality, we have that y is less than or equal to 2. That means the direction of our arrow goes to the left. And also, from the second inequality, we have that y is greater than or equal to minus 3. So that means the arrow moves to the right, which joins up to meet the other line. So this gives our graph for this solution. So next, we're going to look into what problems involving inequalities. What problems involving inequality. Now under this, we're going to be using the normal steps we know when solving what problems that involves equations. The steps are there on your screen. So taking the first example, which we have which you have on your screen. We're going to use the steps to solve the example. Now the example says commercial buses charge 100 naira flats in addition to 50 naira per mile. Morgan has no more than 300 naira to spend on a trip. Question 1. Write an inequality to represent Morgan's situation. Number 2. How many miles can Morgan travel without exceeding his budget? And we are asked to justify our answers. Now, looking at the steps we have there, the first step there says we need to assign a variable to our unknown quantity. Now, you ask yourself, what is the unknown quantity here? Now, the unknown quantity here is the number of miles that Morgan can travel. We don't know the number of miles that Morgan can travel. So we say, let's number of miles be m. Now we've assigned a variable to our inequality. We've assigned a variable to our inequality. Now, step 2 says that we should identify all terms and the symbol for the inequality. Now, we need to identify all the terms involved. From the first statement, we have that buses generally charge 100 naira flat. So that means there's a flat rate of 100 naira. Now, going to the next statement, we have that in addition, translating this to a mathematical statement means a plus sign there. Then, in addition to 50 naira per mile, 50 naira per mile. And we all know that per in mathematics denotes multiplication. And we have that for each mile we have m. We represented our unknown value as m. So 50 naira per mile denotes 50 per, which means multiplication times m gives 50 m. And we have that Morgan has no more than 300 naira to spend. So Morgan's amounts, he has no more than 300 naira to spend. That means he can't exceed 300 naira. Now, no more than 300 also denotes less than or equal to. So Morgan can't spend above 300 naira. So when the statement says Morgan has no more than 300 naira to spend on the trip, it denotes less than or equal to 300 naira. Now, we are now asked to write an inequality. That's the next step. To write the inequality that represents this statement. So from our previous steps where we identified all the terms, to write the inequality means to write all these statements we've extracted here. So from the question which says commercial buses charge 100 naira flats in addition to 50 naira, we have 100 plus in addition to 50 naira per mile, which is 50 m. And Morgan has no more than 300 naira to spend, so which we have as less than or equal to 300 naira. So this is the inequality that represents the above question. So after writing our inequality, the next thing to do is to solve the inequality. We need to know the number of miles that Morgan can travel based on the amount he has, which is no more than 300 naira. So to solve this inequality, we are going to subtract 100 from both sides. So subtracting 100 from both sides, we have 50m is less than or equal to 200. To get the value of m, we divide both sides by 50. So dividing both sides by 50, we're going to have, taking this point, we're going to have that m is less than or equal to 4. So now see that our solution is m less than or equal to 4. Now what does this mean? This takes us to the next part of the question, which says we need to justify our answer. Now remember, the question says we should calculate how many miles Morgan can travel without exceeding his budget. So for this solution to satisfy our inequality over here, this means that if Morgan has 300 naira to spend, that means the number of miles he will travel is not going to exceed 4 miles. Because the inequality here says that n is less than or equal to 4. So now let's put 4 into our inequality and see what happens. So we have 100. So we need to check. We have 100 plus 50 multiplying 4 less than or equal to 300. So from here, we have that 100 plus 200 is less than or equal to 300. Now 100 plus 200 gives 300, which is less than or equal to 300, which is true. Now we can also check if Morgan decides to travel only 2 miles. Now we can see, now let's check if Morgan decides to travel for 2 miles. Now let's see what happens. So we need to check if m equals 2. That means Morgan is traveling for 2 miles. Let's see if his amount will be exceeded. So putting 2 in our inequality, we have 100 plus 50 multiplying 2 less than or equal to 300, which we have 100 plus 100 less than or equal to 300. So from our left hand side, we have 100 plus 100, that gives 200, which is less than or equal to 300, which is true. That means Morgan can travel for 2 miles. But now, what if Morgan decides to travel for more than 4 miles? What then happens? So I would like you to check and see what happens. So your assignment is there on your screen. Make sure you do your assignments. And if you have any question, you can simply ask in any of the available channels. Thank you for watching.